going to see about theorems in polynomial. So first we are going to see about the remainder theorem. So what is the theorem states? If p of x be any polynomial of degree n greater than or equal to 1. So the polynomial of degree, the degree should be greater than or equal to 1. So like that we are taking a polynomial and we have a real number. So what is meant by real number? It is a combination of rational number and an irrational number. Okay, you can take it in simple like that. So that is a we are taking. So a being any real number. When p of x is divided by, that is the polynomial, it is divided by linear polynomial. So the divider is the linear polynomial, that is g of x is equal to x minus a. In common we are taking like that. Okay, so linear polynomial means, you know, is it? It's a degree of 1. Okay, so the polynomial of degree 1 is a linear polynomial. So that polynomial we are taking and we are dividing that. Okay, dividing the polynomial p of x, and then we are getting a remainder. Okay, so we are getting a remainder. That remainder is y of x. So y of x we are taking that as a remainder. So that is we are taking as, which is equal to p of a. So y, the a which is going to substitute in this polynomial, that we are taking like that, and focuses on finding the remainder. So we are going to focus on finding the remainder. Usually we focus on finding the quotient, is it? But according to this remainder theorem, we are going to focus on the remainder. So that is what we are saying, that this is a remainder theorem. Then you take an example, you can clearly understand, I hope. So we'll move to the example. So the example is, find the remainder when x cubed plus 3x squared plus 3x plus 1 is divided by x plus 1. So why I am putting this one as a p of x? This is a polynomial which is given. This is linear polynomial. Okay, so the linear polynomial is x plus 1. So according to our theorem, it is g of x. So when you compare with the theorem, it will become that g of x. Okay, so now what I am doing in the first step, I am equating this g of x to the equal to 0, as we usually do with the zeros of polynomial. We are doing here. So the x plus 1 is equal to 0. So when you take this x from left hand side to right hand side as it's 0 over here, we need the value for x over here. So the value of x over here is minus 1. As you take from left hand to right hand side, it will become minus and it will become minus 1. Now, coming to the point, like y of x is equal to p of a. Could you remember this one that we see in the theorem? Okay, the same thing. So now that real number, which is that real number now over here, it's a minus 1. So the minus 1 is a real number. So p of minus 1. Now what is our thing is, we are going to substitute this minus 1 in the given polynomial. So the given polynomial, this one we are substituting. So in the place of x, we are putting minus 1. Here also in the place of x minus 1, in the place of x minus 1. So as you already know when you study about the integers and all, when it's minus 1 the whole cube, the answer will be the minus 1. It's minus 1 the whole square, the answer will be the plus. So it will become plus 3, and of course 3 into minus 1 gives the minus 3. So the minus 3 and the final one is plus 1. So when you calculate, so everything will goes and comes to 0. Okay, so now what is the remainder over here is 0 is the remainder. Okay, so the remainder theorem gives, we want to find the remainder, so we got the remainder as 0 over here. So that means it's divided, exactly this linear polynomial divides the given polynomial. That is the meaning over here. But what is our, through the remainder theorem, we found the answer for this. The remainder is 0 over here. So this is how we find the remainder for the given polynomial using the remainder theorem.